basically how air is going to be introduced to a room that affects a fire. So what I'm doing is I'm pouring ethyl alcohol or ethanol onto these ceramic fiber boards. We use it for insulation, but in this case, it's basically a wick that's going to absorb the fuel, so this doesn't get everywhere. It's not going to burn anything like that. The reason we're using ethanol is these hoods work pretty well for exhaust, but other fuels are a lot more smoke. You're not really going to see any smoke, and after burning all day, we don't want this place filled with smoke. So I don't want to quiz you too hard, but the whole point of this is I'm going to have this door, imagine this, and there's a hole in this wall right here. I'm going to open and close it. What do you guys think is going to happen when I either open it or I close it? So, okay, is the fire going to get bigger or is it going to be smaller?
Bigger when you open it.
Bigger when I open it?
Yep.
All right. So I'm going to light it off and we'll see what happens. So right now it's open. I'm going to let it build up a little bit. And then I'm going to close the door. So you're right. So almost immediately the fire dies down. Because of the fuel, there's not a lot of air. It's going to be a bluish color. It's going to be a lot smaller confined to that room, but as soon as I open up this door, it flares back up. It's a lot bigger. Now I can see from this view, I can see it in this other room. And essentially, this is modeling a real fire that happened. I'll explain that with this model I have over here. But fires in here, this is a stairwell. We don't have a floor in between these two levels. So the fire is going to burn in here and then travel up this stairwell and vent out that one side. And the reason this is happening is when this door is closed, there's only one ventilation source for this room, and that is this hole over here. So it's called bidirectional flow because on the bottom imagine this is that doorway, on the bottom we have air coming in, and on the top we have, if there's a lot of smoke, we'd have smoke going out, heat's going out. But when I open this doorway, I have oxygen coming in on the bottom, only oxygen, and then basically only smoke and those byproducts coming out of the top. If this was a lot sootier fuel, you wouldn't really see any smoke coming out of here. You'd see it really only out of that door. And the reason is, hot airs like to rise, or hot gases like to rise, so they're going to go in, burn, and it's going to rise up to that higher vent. And the reason, we have this set up is there was a fire that occurred about 4 years ago that killed a firefighter, and the reason was because of this. On the right, you can see a model of if that door was closed, and then on the left, you can see as if that door was open. That was actually the case where the door was open. So you can see the fire, with that door closed. With the door closed, it mainly stayed in that room. It didn't really extend outwards anywhere. But because that door was open, the fire was allowed to travel up that stairwell. And I believe the firefighter was on the third floor where he entered. And, it eventually caught, if that's a couch or something, caught the contents and that room on fire. And that, unfortunately, was enough to kill him. And that was a model done by the ATF. Some of the things that they do is they go into a post-fire scenario, investigate and see, how did the fire occur? In this instance, why did the firefighter die? What happened in that fire to ultimately cause his death? And we can use fire modeling for that situation. We're able to recreate that model accurately, without burning things. Because it's not always, you can't just go into a house and burn it. It's not always practical. And with this is nice because you can see it, but it's a small scale, and small scales don't always replicate, larger scale scenarios. It doesn't necessarily transform exactly. So with these computer models, we're able to see accurately what took place. But another cool thing, we're talking about ventilation. It's nice and all to talk about, but this is seen in fire protection all around. If you guys look at this door back here, see at the top, that's an automatic door closer. And the reason for that is, if there's a fire in this room, I wouldn't necessarily think when I'm running out to shut the door behind me. And in this case, that's probably what happened. There's a fire in here, they were in there, they left, but they forgot to close the door. So we kind of remove that source of error by having those door closers on there so that if there is a fire here, it stays here. That door is rated for an hour and a half, so if there's a fire in here, we have time for the fire department to come, stretch out their hose lines, and ultimately extinguish it. So, a lot of times if you know what fire protection is, people think, oh, you guys design sprinklers, and that is one thing that we do. That is one thing of multiple things that we For this room in particular, an engineer had to think, all right, I have to put sprinklers in here, but what type of sprinklers do I need to put in this room? How far apart do they need to be spaced? We got to think about what materials are going to be in here that are going to burn. I mean, how flammable is the stuff in this room? Like, I know that, all these components, they're metal, they're not really going to burn, but we're going to house chemicals in here that are flammable. You have to take that into consideration. If you guys have been down to the Kim Building Plaza, where we have some stuff, we had 2 model houses that were built. They can explain it to you down there. If you go down there, they have videos and stuff. But 2 model houses that were showing the difference between what materials being used today for construction and furniture, how they burn in comparison to stuff they used 30 years ago. In that case, stuff 30 years ago, the house didn't burn down. It's still there. You can see it. But the structure that we made out of newer materials, housed with new materials, all that's left is a piece of charred wood on the floor. So there's a stark difference between materials that are being used now and 30 years ago, and we need to be cognizant of that when we're designing our stuff. And that's why a lot of the sprinklers are being used in residential homes now that are being constructed, because the materials burn more readily. We have to put sprinklers in there to kind of mitigate that problem. Let me see if they're ready for this. You guys have any? I know I talked a lot, maybe a little fast. You guys have any questions about anything?
Nope.
Yes.
Just a lot of the newer houses that are being built with very open floor plans, is that actually more of a fire safety hazard in the home than older houses that are more?
Definitely. So that was actually one of the, if you go down there and look, the house that is still standing that we have, we just have the first floor, we took the second floor off. It's a lot more compartmented, it has a lot more rooms. Versus the other half, the other house had a large atrium in it, a lot more open floor plan, because that's what people want these days. You go to offices, they're getting rid of cubicles, they're getting rid of those walls because they want it to be open, it feels nicer, but you don't have those walls to stop fire from spreading. So it's definitely something that we have to look at, and that's why, I think pretty sure in Europe, Dr. Sunwood, in Europe, they use a lot more compartmentalization, right, with their building.
Right.
They don't use sprinklers as much.
Less wood in their construction.
Yeah, so in Europe they use less wood, they compartmentalize more, but they don't use sprinklers as much because you have less combustibles, you have that compartmentalization to stop the fire from spreading. Here, we don't compartmentalize as much, we use more flammable materials, and because of that, we tend to use sprinklers a lot more. So, those are kind of, we can think about all these things when we're designing stuff. Okay. Any other questions? All right, I'll see if you're ready.